Hi. Oh my God. Can you guys hear me? Great. So I'm Yarden, and today we're going to talk about how our mindset needs to change when coding in Go versus in OOP languages such as Java. Let me start by introducing myself. I'm a software engineer at Rookout. I come from a background of low-level programming in C and Linux IoT environments. And I really, really love learning new technologies, new programming languages, and a lot about how they work behind the scenes. Now, at Rookout, we're developing a debugger for production. Yes, it's 2022. It's about time we can debug in any environment our code runs in. We have a debugger for 6 different programming languages, and I'm on the team that develops that debugger. So we recently released our Go SDK, which means that a lot of the work in the past year has been on that project. And a lot of my work personally has been on that project. And one of the first tasks I had when I came to Rookout was to translate a section of code from Java to Go. And there's a lot of things I learned from that. And then this talk is based off of that experience, the mistakes I made, the tips and tricks I learned along the way. So let's get into it. Now, I know that most of you probably don't have a deep background in Go, and that's fine. We'll go over the basics, and we'll gradually make it more advanced, more complex. The point of this talk is not to teach you the syntax, okay? You won't leave after 40 minutes and say, wow, I know how to code Go perfectly. The point is to teach you how to think in Go. You leave this talk and you might need to search up how to declare a variable or define a function, but you know how to design your code correctly with Go in mind. So let's start. Very, very basic beginning. Let's just see how we define variables and define functions. There's 2 ways to define variables. The first is with the walrus, right? The 2 dots and the nose. And so this way we're defining greeting. It's going to be a string. Its value is going to be hello. Very, very simple. And we can use the var keyword. In Go, we like things the other way around. So we like our variable names before their types. So in this case, we're creating a variable called name. And its type is string, and then it's just initialized to be an empty string. To define a function, we use the func keyword, give the name of the function, in this case, greet. Once again, we want the name of the variable before its type. And last but not least, the return value. There can be more than one return value. It doesn't really matter. In this case, there's one return value. Its type is error. In Go, we don't have exceptions. And you might all be rolling your eyes, but believe me when I say that debugging errors is much easier than debugging exceptions. Now, this is the body of our function. We're printing hello and then the name. And we're returning nil. Nil is the Go null. Great. So let's jump right into it. Let's take a very, very simple project. Let's say a logging library. We'll take that project, we'll write it in Java, and then we'll try to translate it to Go. So our logging library is going to start very, very simple. We need to support multiple log levels, and we'll have a function for each log level, so it'll look something like this. So we have our 5 log level functions, and at the end, they will all call an inner write method, which will actually write the log message. So let's see how that would look like in Java. Well, we'll declare a class, right? Everything is classes in Java. So we'll declare a logger class. We'll create a write function, which just prints to stdout, and then a debug method, which calls that write method. Very, very simple. Putting it all together, we can create a logger instance, call the debug method, and print to stdout. Great. Now the same thing, but in Go. So we obviously haven't learned enough to be able to write this. And the first question that comes to mind is, how can I translate that logger class? How can I create a class in Go? And unfortunately, the answer is Go does not have classes. But don't fret, read a little more, and we'll figure out that there's something called structs. So structs are the classes of Go. Let's talk about how we use them, how we declare them, what they can have. So first of all, we'll use the type keyword. The type keyword comes before any type, not just structs. The talk is the name of the struct, and then the struct keyword to say that this type is a struct. Now we can decide which fields we want. In this case, we have two fields. We have speaker name and slides. You'll notice that speaker name starts with a capital S and slides with a lowercase s, and this is Go's way of saying speaker name is going to be a public field and slides is going to be a private field. There are no keywords public or private in Go, and the protected accessor just doesn't exist. Another thing we can see here is the slide type. The slide type isn't a type that comes with Go. It's a user-defined type that somewhere else I just defined type slide struct, just like I'm doing with talk here. And it's an array. That's why we have those square brackets. Great. Now another thing we can define on structs is methods. So this is an example of how we can define the is_Yarden's talk method on the talk struct. So one thing that's kind of different than the function declaration that we saw before is the ttalk in parentheses. And now our ttalk is going to be our this, right? In Java, when we create a method, we put it inside that struct's body, kind of, the class, sorry, not struct, the class's body, and then we just automatically have a this. Well, in Go, it doesn't work that way. We decide what the name of our this will be. And in this case, I said my this is going to be t, and its type is talk. So if I wanted to access speaker name, which is a field on my talk, I'd do t.speakername. In the same way, I could have called a method that was defined on that type. Great, so how do we use these structs? Well, we can initialize structs like this. So in this case, we're creating two variables, right, with the walrus symbol again, Yarden's talk and other talk. We specify the type of this struct, right, the talk, and then we can choose to initialize how many ever fields we want. We can choose none, we can choose all of them. In this case, we're initializing speaker name, and slides is just going to remain nil. Now, in order to call the is_Yarden's talk method, just as we would in Java, right? You've created a variable of a class type. You want to call a method dot that method. And this is going to return true on the first one and false on the second one. I really hope you guys understand why. Great. Now let's jump back to our logger. Once again, same design. We're going to have our 5 logging levels, and they're all eventually going to call that right method. So instead of using classes, we're going to use structs. So we have our logger struct, and we're going to have a write method, which is very simple, just prints to stdout. And we're going to create a debug method, which calls that inner write method. Very simple, very straightforward, very similar to Java as well. Putting that all together, we can create a logger instance of that logger struct called the debug method, and we're printing to stdout. I hope you're all wondering, why do I need Go? It sounds exactly like Java. We'll get into it. Now, let's say we have some new requirements for our logger. We don't just want to support multiple log levels. We also want user-defined logging targets. What does that mean? That means that by default, we will log to stdout, but if the user wants to log to, say, a file, we'll allow him to do so. So let's implement that in Java before we jump into Go. So that was our basic logger. And now we're going to extend it into a file logger. So we'll use the extends keyword, right? We're using inheritance. We're promoting file logger will have the same fields and methods as logger. And then we can use the override annotation and override the write method and write to a file instead of stdout. Great. Putting that all together, we can create a file logger instance, call the debug method, and, oh, sorry, what happened? Okay. And write to a log. Great, everything works. Now in Go, and once again, we're missing some knowledge here, so let's learn. Well, in Go, there's this thing called embedded structs, which means that you can embed a struct in another struct. In this case, we'll take the same example that I took as before, the talk struct with the speaker name and slides fields and the is_Yarden's talk method. Now, in this case, I do want to create a different struct that will embed this struct. In this case, the struct will be Voxxed talk. And the right way to say this is that Voxxed talk embeds the talk struct. And that means that the fields and methods I declared on my talk struct are now promoted to my Voxxed talk struct. So creating a variable that's type is Voxxed talk, I can access speaker name, though it was declared on talk, and method, which was, again, declared on talk, and they will both work exactly the same. Sounds a lot like inheritance, right? Sounds a lot like concept we know from Java. So let's try and go back to our logger. Well, let's use the same methodology, right? If we inherited from logger last time, let's embed logger this time. So we're going to create a file logger struct. We're going to embed the logger in it. And I just added this file name field just so that we could have it there. It is important at the end of the day. We will need to know which file to log to. And we'll have that write method. Now in Go, we don't have annotations, we don't have decorators, we don't have things like that. So I'm just going to write the write method and hope it overrides. Great, so we'll do the same thing. We'll create a file logger instance. We'll set the file name to be whatever file we want to log to, and we'll call the debug method. Now what we expect to happen is for it to log to a file. But what really happens is that it logs to stdout. So this is a bug. This is a problem. Let's kind of try to understand what happened here. Well, in order to understand what happened here, we have to know a little bit more than just the Go syntax. We have to know how Go works a little bit behind the scenes. First of all, declaring a method in Go is no more or no different than just passing that type that we declare the method on as the first parameter. So in this case, I created the debug method on logger, but it's not really that different than just creating a debug function with logger as the first parameter. Another thing is that I kind of lied to you about embedded structs, and I'm sorry about that, but they're not like inheritance. Sure, the fields and the methods get promoted, but it's kind of a wrapper for just a field. So in this case, embedding logger and file logger is kind of like creating a logger field inside file logger. And creating that field, that's not enough, right? Because we want access to the fields and the methods. So accessing the method is kind of like creating a debug method that's a wrapper that just calls the inner debug method of the logger itself. So that was a lot of explanation, but let's put that all together and see what actually happened here. Well, first of all, we created a file logger instance, we initialized it, and we called the debug method. Now that jumped to our wrapper, right? We didn't write the wrapper, Go did that for us, but it's the same thing. Now we called the debug method on our logger, so we jumped to this method, this one. Now, at this point, we've lost all reference to our file logger. Logger doesn't know where it came from. It doesn't know it was a field on file logger. It doesn't know any of the context of this whole talk. It knows nothing. So when we call the write method, we're actually calling the write method on logger, and we're printing to stdout. So I hope we now know what our bug was and what our mistake was. Yeah, so that was the problem. That was like the practical problem with our code, what caused the bug. But our real problem was that we were trying to translate code from Java to Go. That might not always work. It worked in the really, really simple case of just a simple struct that didn't do much. But then once we tried to add a little bit more, I don't know, make it a little more generic, less redundant, more abstract, well, it didn't work. Basically, what I'm saying is that we weren't planning our code with Go in mind. So what's the solution to this very big problem? First of all, get to know Go's features. I know I'm the one who told you the features, and I probably should have told you the whole story, but we'll leave that for another time. But it's not enough to know the syntax. It's not enough to know, oh, you can embed a struct in Go. That's really nice. I heard the fields get promoted. You need to know how the syntax work. You need to know the edge cases. And you obviously need to try it out before just going and implementing it in a large code base. Another thing is don't try to translate coding concepts. Go is very different. It was built with trying to innovate, trying to take the good of all programming languages and leave the bad out. I don't know if it succeeded in that, but when that is the mindset, a lot of things that might have worked for you, they consider a hack. so they don't allow it in their code. So trying to translate might just leave you with these quite unrecognizable or undetectable bugs. And another thing is Google everything. So this is probably not news to any of you. Stack Overflow is a developer's best friend, but a quick Google search can save you so much time, and it could improve your code so much with just little changes. And I'm going to show an example of all of these. So back to our practical logging solution. First of all, I'll start by saying that there's more than one solution. I'm going to discuss more than one solution here today. Second of all, we need to return to our goal. Like I said, we're not translating anymore. We're building a new project, and we need to build with that in mind. And the third thing is interfaces. Now, don't worry. I'm going to show you what those are. So first of all, interfaces are basically just a group of functions. Not function definitions. They don't have, obviously, the whole implementation. They just have the declaration. Interfaces are implemented by structs, and they're implemented implicitly. That means that they are much more lightweight, right? In Java, to implement something, you'd need the name of what you're implementing. In Go, you don't need that. That also means that you could create a struct and then create an interface and have that struct implement that interface without even knowing. And the last thing I'm going to say about interfaces before we dive into them is don't design with interfaces, discover them. This is a quote from Rob Pike. He's one of the creators of Go. And this is very important just because interfaces, because they're so lightweight, they're so easy to use, they're so easy to implement, they tend to get abused. So the saying is more like, don't use interfaces because maybe it'll make your code more generic and it'll be good to use one day. But create an interface if you need it today, if you need it now. Now with all that, let me show you a quick problem. Well, we have 3 write-to-file functions. One of them is the source is a file, the source is a buffer, and the third, the source is a socket. Now, obviously, I haven't showed you the implementations, but we can all guess that the code is going to be pretty similar. There's going to be a lot of redundancy between these functions. And so let's use interfaces to solve this problem. First of all, in order to define the interface, we're going to use the type keyword, just like we did with a struct. We're going to use the interface keyword, and in this case, our interface name is reader. And we just have one function in this interface. I could have added more, but there's no need. So we have the read function. It does not accept any parameters, but it does return a list of bytes, an array of bytes. Now, we can change our 3 write-to-file methods into one write-to-file method which just accepts this reader. And then, since it accepts this reader, and this reader surely has the read function, it can call that read function, save it in a buffer, and then write it to a file. Now, let's add the last missing piece of that puzzle and actually implement that interface. So I only implemented this interface for the file, but you can kind of guess how it goes for the other 2. So I've created a file reader struct, very, very simple. And then I've just implemented the read function, and that's it. File reader doesn't know of the existence of the reader interface. It doesn't know that it implements it. All it knows is that it has a read method, and that's fine. And now we can create a file reader instance and just pass it as a reader to write to file. And we've just saved us so much code, right? A bug in one of those write to file functions before the interfaces would have probably been in the other 2, and we might have fixed one, but not the other. In this case, we have one source of the code, and that's the better solution. So now that we know how interfaces work, let's get on to our logging solution. As I promised, there will be more than one. Now, the first solution is to create a logging target interface, create a write method for that. This write method doesn't return anything. It just accepts the message parameter. And in Java, you need everything to be a class, but in Go, it's not that way. So in this case, I'm just creating a global variable, which will exist everywhere, and its name will be target, and its type will be logging target. Now I can create a debug function. Again, it's not part of a struct. It's not inside anything. And just call the write method on my target. Now I can create a standard logging target and implement that write method, print to stdout. I can create a file logging target. In this case, I did want more control over how I created it. So in Java, you have constructors, right? Well, in Go, those don't exist. But what we usually do is just create a constructor ourselves. So in this case, I'm creating new file logging target. And I kind of expect everyone that uses file logging target to create them using this file. So now I control how the file logging target is created. And I will implement that write method again. So both file logging target and standard logging target are implementing the logging target interface. Great. The only thing missing is changing that logging target. So I created a set logging target function and just changed it to the new target we want. So in this case, we can create a standard logging target, set it to be our logging target, call the debug function, and write to stdout. We can also create a file logging target, set that to be our logging target, call the debug method, and in this case, it works. We're logging to a file. Now, there's a few pros to this. There's also a few cons, but this doesn't require passing around the logger everywhere, which is pretty nice. And also, any logging target can be easily implemented and accessed globally. But as I said, a better solution usually exists just one Google search away. In this case, we have the writer interface. This looks a lot like our logging target interface, right? Well, this interface exists as part of the standard Go library, which means it exists in any Go binary you find out there. Now, if we do just a small change and change our target from logging target to io.writer, io is the package in which writer comes in, then we can just use standard types like os.stdout, because os.stdout already implements the io.writer interface. So just like that, we don't have to create our standard logging target struct anymore. Set that to be our logging target, call the debug function, and we're printing to stdout. This happens with the file as well. We can call os.create, which creates a file, set that to be our logging target because it already implements the io.writer interface, call the debug function, and log to a file. Actually, this small change caused us to support out of the box with no need for extra code, buffers, sockets, files like we saw, hashes. I don't know why you would want to log to a hash, but if you do, it's possible. Actually, there are 351 types that implement the io.writer interface in the standard library alone. So just this small, very, very small change made our code much easier to use and us to be able to use it with many different types. Now, what if we were to log to multiple targets? Or we wanted to decide on where to log to depending on the function or the package or whatever? Well, basically what I'm getting at is that our logger needs to be a struct, or an object, which is a struct in Go. So in order to do that, we can create the logger struct. We can have a field, which is a writer field, right? We'll use that io.writer type again. And then we can wrap the initialization in a new logger function and pass it a writer, return that logger from the constructor. And then we create a debug method and just call that writer's write method from here. So once again, we're creating a very simple solution, but we're not using inheritance. We're not using embedded structs. This might actually be easier or simpler than the previous implementation that didn't work. So we can create a new logger with os.stdout, call the debug method, and print to stdout. We can also create a file, put that to be our target in the new logger, call the debug method, and write to a file. So what changed in our mindset to allow for these solutions to work? First of all, we stopped thinking in terms of inheritance or in terms of translation. We're not extending our logger or overriding a default behavior. We're injecting a custom behavior, which allows for the same struct to behave differently depending on what we injected. We're also taking advantage of Go's features, of Go's standard library. We found an interface and used it instead of our interface, and we're just supporting so many types now. We also gave up on trying to translate our Java logger to Go. Extending and using the Java logger and the Go logger will be completely different, but that's okay. They're not the same programming language. They're not supposed to look similar. We got the same level of reusability, flexibility, modularity without relying on some OOP concept. And this is possible in even the most complex system. We don't need to rely on OOP concepts to create this level of modularity, flexibility, reusability. To summarize, I think that Go is not a very OOP language. This is a big question. There are a lot of opinions on it, but this is mine. But even if you think that Go is OOP, we can't always rely on those OOP principles when coding in Go. We might just need to figure out the Go way to do things. So what next? Well, if you like this talk, if you liked hearing about Go, if you want to hear more about Go, I suggest a few topics to learn. There are so much more, but pointers, arrays, slices, packaging, generics, channels, and Go routines are just a few of them, and they're what make Go really unique. And that's it. Thank you so much for your time.